Hello, and welcome to our virtual office hours series for MindTap General Chemistry. My name is Janet Delmundo. I'm the Senior Marketing Manager at Cengage Learning. I'm thrilled to introduce one of our presenters for today. Professor Bill Vining from SUNY Oneonta is one of the co-authors of MindTap General Chemistry. I'll be handing the control over to you, Bill.
Thanks, Janet.
Just right now.
Okay, I'm going to share my screen. And the two people who are going to be doing these weekly or bi-weekly sessions are myself and Susan Young, who's another one of our co-authors who teaches at Harvard College, and our other co-authors are Roberta Day and Bea Botch, who are professors or have been professors at UMass Amherst. So what I'm going to do today is do an introduction to MindTap and how it works, and some of the features and some of the philosophy behind the way the system operates for both students and for both instructors. And so this is my MindTap landing page when you log into your Cengage account. And so I've chosen the MindTap book, and I have two courses going at the moment. I have a Chem 111, which is a Gen Chem 1 course that I use it for, and I use like 3 chapters or 4 chapters of it for a descriptive inorganic course. So I'm going to go into my Gen Chem 1 course. And when I go in, it generally starts up with a view that the students have of what their weekly workload is. And so my students are, we're finishing chapter 3 this week, and which is stoichiometry, so they're doing reaction stoichiometry. There's a set of assignments due tonight at 11 o'clock, and you can see that the students are now working on it because it's the day it's due. And so 62% have submitted it, the first one, and 31% have gotten through all 4 of these nuggets. And then the next set of assignments are due on Sunday, and they're not hardly worked on at all, as what you would expect. So what I'm going to do is I'm going to go into a chapter and show you the different kinds of modules that the students can use. And so this is the weekly view, so the students can see what's due each week. And I'll show you how that works a little bit more later on. But right now I'm going to go into kind of the chapter view or the unit view. And so I'll jump ahead to thermochemistry as an example. And so the system is set up just like a regular textbook, where there's an introduction to a chapter, there are sections in the chapter, and then subsections that are the smaller nuggets of information you have. But it's all built so that it's an assignable system, so the students are working through the text material by both reading the text and answering questions that are embedded in the text, and then doing regular kind of end-of-chapter problems, but that are mastery-based. And so the way it works is at the beginning of each chapter there's an introduction and quick prep assignment. These are generally assigned for practice as opposed to for grade. That means they're optional, but you can change that if you want. And what this is a series of questions that revolve around things students should have learned either in earlier chapters or before even coming to college that will be useful for them to do this chapter. And so there are 10 questions here. And students go through, and so the first one is an algebra question, rearranging an equation. And you'll see that what we do is we use chemical type symbols and variables for how to do that. So essentially, how would you rearrange this equation? Here's another one for doing more algebra practice. Here's one for significant figures. Here's one for dimensional analysis, unit conversion type things. Here's a dimensional analysis problem. Let's see what happens when students get this wrong. So I'm going to say that there are 567 days in 14,400 minutes. I'll get that wrong. First, this is an error, so I can check my answer and try to get it right. And I'll say, well, maybe it's 79, 69. It's not. When I check that, what it does is it says you're wrong, but here's how to do it. So it gives me an exact example about how to solve this particular instance of the problem. And then the student gets to try another version. And so now it's the same kind of question, but with a different variable. And as we'll see later, that parameterization of the information in the question extends beyond numbers to it'll include different chemical systems as well as different ways the questions can be worded. So the students go through this introduction and quick prep and basically just refresh themselves about the kinds of things they need to know before they really do the information on this chapter. Then they actually start digging on the real content. And so I'll jump ahead to, let's say, section 5.3, which is about heat transfer and specific heat. And so 5.3 has 3 different subsection reading assignments. So sections that have a number in it, letter A, B, C, those are reading assignments. We call them interactive reading assignments. And they're graded reading assignments. Let's jump to like 5.3b, for example. In 5.3b, what we have is we have some text along with some interactive information, interactive conceptual exercises, and homework problems. So we're going to start that activity. And it starts out with some information, some description of what we're talking about, which is heat transfer, thermal energy transfer, a definition of thermal equilibrium, which you can pop that up. And then there's a figure that shows, okay, if you take a block of wood and a block of aluminum and put them together and they start at different temperatures, they end up at the same temperature later on. And so that's the kind of thing that would be in a textbook with a significant caption under it. Instead of just having a caption, what we have is we have an interactive exploration of that. And so students open this figure up, and what they have in this case is a simulation based on that example. So they can choose different substances. In this case, we'll have wood and wood, 2 blocks of wood. We can make one at 10 degrees, one at 71 degrees. And when you combine them, bring the blocks of wood together, it'll show numerically and diagrammatically what the final temperature is. Let's instead try a different thing. Let's try copper and wood and combine those. And what happens is the temperature ends up much closer to the initial temperature of the wood because it has a much higher specific heat capacity, which will be explored throughout this. So what happens is the introduction to this tells the students about what they're doing and how to use the simulation. And then it has a series of questions. And the questions lead the student through using the system. So it'll say, select 5 grams, a 5-gram water sample for each of the 2 samples, set 1 to 20 degrees, 1 to 40 degrees, and combine and figure out the temperatures. And it'll lead them through an exploration of, in this case, thermal equilibrium and heat transfer to give them the gut feel for what it is that we're talking about in terms of temperature changes and substances. Then, as we move down, there's some more text, another figure. And this figure then is a figure all about energy diagrams, or enthalpy diagrams in particular here, where the students have this figure, and part of our philosophy is that diagrams and figures and graphs are really important for students to understand concepts, understand just chemical information. And so we want them to actually spend time thinking about it, and we do that by assigning points to it. So the students go through, and we have, for this example, we have an example where we take a bolt, or is that a nut? And sorry, let me go back. A video of an experiment where a nut gets heated up and plunged in some water. I'm not going to take time to do it. Plunges in water, and the water goes up in temperature. So you weigh the nut, you heat it up, you plunge it into the water, temperature goes up. Then what we do is we build an enthalpy diagram based on what happened in that system, in that example. So when the hot iron is plunged in the water, the temperature of the iron clearly decreases. This represents an increase or decrease in enthalpy of the iron. So in that case, it's decrease. So when students get that right, what it does is it starts to build the diagram for them. Should the final state for the iron be higher or lower? It should be below the initial state because it has lost thermal energy. And then it shows the change for that. And it goes through and then finishes doing the enthalpy diagram overall for the whole system and what changed there. When they get done with that, they get a point for it. And so the students have their points up here, and they know that as they go through and do their reading, along with actually reading the text, they have to do these things and get these points. So they'll go ahead and do that. Down further on, there's an example problem. An example problem is just like one would be in a traditional textbook where you have a problem listed out, and then it does the solution. The solution has some pedagogy to it. In this case, it says, what are you asked? Identify what you're being asked to do, and also identify what you're given. What information do you have? And then it goes through an example of how to solve for it, and then has a little paragraph on analyzing your answer to see if you think it's reasonable, which students should be doing. Then we have a video solution of this. So we take that same example, and we walk through it talking about it as you're listening to this recording right now, that there's a recording of this where an instructor, closed caption in this case, I can turn that off, an instructor, one of us authors, walks through that problem, writing on the screen and doing essentially a Camtasia video of that. And so the students can watch someone solve that problem and listen to it if they learn better that way. And then finally, the students have their own problem to solve. So they open up and example this problem, and it's the same kind of example that they did, but now it's got different substances in different amounts. So instead of this example up here, which was copper and ethanol, we now have lead and ethylene glycol. And each time you come up, it'll be different stuff and different amounts. And so when the students try this problem, and this is again, of course, for credit, they try to find thermal equilibrium here. So I know it has to be between 13 and 62 degrees, so I'm going to say it's 19 degrees. And that's probably not right. It says you got a mistake. Students can try one more time to solve this instance of the problem. They get that wrong. It says they're wrong, and they have two options. One option is to look at the solution. So they can say show solution. And then they look at an example of how to solve that problem, similar to the one they just saw in the example problem above, the static one. And then they can try again. And when they try again, they get a different version of the problem. And so then they've got lead and ethanol instead of ethylene glycol. And I'll get that wrong again and show the next option for the students. If they get it wrong, they can say tutor me. And if they tutor me, what it does is it opens up a step-by-step walkthrough of the problem. So the students are asked to walk through the problem step-by-step to get from the information given to the final example, the final answer. When they get that done, they can then go ahead and try again. The students it's the standard for this is 5 tries, and an instructor gets to change that in your settings when you assign things, but 5 seems to work well. And so the students then do these example problems, tutored practice problems, which are associated with the example problems, as part of their textbook reading. And so as students go through each subsection, they do the reading, they look at these interactive examples, and they do example problems. And so basically what this means is reading their textbook and engaging with their textbook is assigned homework. And that's what we do. So the students go through, they do their reading assignments. So for section 5.3, they'll do heat transfer and specific heat capacity, where they learn about just specific heat capacity. They learn about heat transfer between substances, and they learn about changes of state and heating curves. When they're done with that, they have a set of homework on that section, and we call that a mastery assignment. And so the mastery assignment is composed of a series of mastery groups, where each mastery group is questioning about a particular topic. And the students are given in each mastery group some number of questions and given some number they have to get right in that set. So the first one is energy and temperature change. The next one is specific heat capacity, specific heat to changes in temperature. Next one is determining either heat capacity or the final temperature for things, and phase change energetics and heating curve energetics. And so what happens is for each of these, so for example, determining heat capacity or final temperature, the students are given 2 questions, and they have to get one of them right. So if they tried this question here and they get it wrong, what happens is they say, I got that one wrong, but I can still do this other one and still get credit for this particular question, this particular mastery group, because I only have to get one of these 2 right. And so if they get this one right, then they master it. If they get this one wrong as well, then they have to redo a new set. And so if they click on Regenerate Group, it gives them 2 new problems that are different than the ones they just had. And then within these mastery groups, again, the chemistry changes, the numbers changes, and oftentimes the way the question is worded changes as well. And so in this one here, where you have specific heat and you're asked to figure out the energy associated with specific heat and a temperature change, what happens is the students have 3 questions, and they have to get this right 2 times. So notice the first question is how much energy. The second question is what is the final temperature, and the third question is another one about how much energy. So the wording of the questions can be different. So the students have to go through then and do each of these mastery groups to complete the mastery assignment for this particular chapter. So what happens is the students they do their reading assignments first, then they do the mastery for a section. Then they do the reading assignments next and do the mastery for that section. And they'll do the reading assignments first and then the mastery for that section. And there's nothing forcing them to do that, but they actually just do it that way. And you can see it in my view, my weekly view here, because here for section 3.3, I just assigned these, and the students just do them in order. So you can see that, didn't even do that back there. So you can see that the students are doing them, like 62% have done the first reading assignment, 60% have gotten through the second, only 40% have done all three reading assignments. So the students are basically, the class as a whole is completing this one before this one, before this one, before this one. So they do the readings, then the mastery. Okay, back to here. So at the end of a chapter, we have two sets of review type exercises. One is a series of review questions. These questions are similar to the mastery questions we were just looking at and similar to the example problems that we had. And as the students go through, the difference between these really is that what happens is I'm in chapter 3 now, not chapter 5. As the students go through and do these questions, the difference between this and the mastery assignments is these are not categorized, so the students don't know what they're about. And so the students have two things they need to do. They need to know how to solve this problem, but they also have to identify what this problem's about, which, when they're doing the mastery assignments, it's telling them, you're now going to do stuff on gram to mole calculations. You're going to do balancing equation calculations or balanced equation practice, and so they know what they're doing. Here, they don't know what the question's about. They have to figure it out, so expanding their skills for that. Similar to this are challenge questions. And so at the end of a chapter, there's also a set of challenge questions. Those challenge questions are essentially, well, they are what they sound like. They're challenging questions. And the idea for them is that what happens is the students have things that are more difficult to answer, oftentimes combining multiple concepts, sometimes just involving harder math, but oftentimes involving concepts from the chapter they're in as well as previous chapters. And so the students can have these challenge questions as well. And you as an instructor get to change things like whether or not students get a certain number of tries, whether or not the students get to see the solution, and whether or not the students can get extra attempts, things like that. So the system comes with a default of students always get to see the feedback, because this is intended to be a learning system, not a testing system, but you can change that. And for most things, students get 5 tries at each thing they're doing, and it's pretty rare that the students actually run out of tries. And if they are, then they should learn to come get help when they're gotten something wrong 3 times. That seems to work well. Okay, so that kind of shows you how the content works from a student for a chapter. Now let's look a little bit from the instructor side. The most important thing that you would have to worry about is how do I assign stuff and how do I see stuff. In order to look at stuff, look at material, this chapter view is really good for that. So the chapter view here, which is that middle section here, is you can go ahead and look at different chapters. So let's say we wanted to look at electromagnetic, let's say electron configurations and periodic properties. All right, so I think what we're going to do now is we're going to now turn to how some of this works from the instructor side. And so the first thing you want to do as an instructor is to know what to assign. And the way to do that is look at the material and decide what you want to assign. Most people assign certainly all of the reading assignments, all the mastery assignments, and then parts of the review and the challenge assignments. And so to review material, you can go into a chapter. This is the chapter view, which is the unit view, which is the middle icon there. And so you go into a particular chapter, and then you can page through and look at the material as you go along. So electron configuration of the periodic table, for example. You go into that assignment, look through it, decide what you want to do with it. For the most part, each of these reading assignments, basically everybody who uses this would assign it. And so they're interactive figures. You can look at what's being covered. You can also do a lot of this with respect to just the physical textbook, paging through that to look at what's covered there. You can look at what's happening inside the interactive figures if you're interested. This particular one is a block diagram of the periodic table in which kind of subshells are being filled at different places. So you kind of know what it's about. And so you can do a review of the material that way very easily, or paging through the textbook. The more important thing for you is how to assign things. So I think what I'll do is I'm going to actually assign some stuff from my live class while we're doing this. So I have Chapter 3 here. We're still doing Chapter 3 in class, but we've done it in a couple of days. So it's time to assign Chapter 4. And so for this particular week, I have my assignments here. I have not yet put assignment for Chapter 4 up. Let's go ahead and do that. The right-hand icon is the Date Manager view. What you do is you can scroll down to the chapter you're interested in or the unit you're interested in. It's Chapter 4. And I don't want to do all of it at once. So I'm going to do the quick prep and sections. This chapter is about survey of reactions. So I'm going to do all of the aqueous reaction stuff at once. So definitions of single displacement, double displacement reactions, combination reactions, as well as reactions in aqueous solution, precipitation and acid base and gas forming. And I want all of those to be due, let's say, next Sunday. So what I'll do is I'll go to this thing here. I will choose a week from this Sunday, which will be October 1st. I'll have it due at 11 p.m. You can change that. You can go all the way down to 11:59 p.m. I want my students to get some sleep. So 11 p.m. it is. I say done, I say apply, and those dates appear here, right there. And then when I go back to my weekly view, I'll see that now in that week, on October 1st, all of these are due. So October 1st at 11 p.m. And so let's say I wanted to make the next set, the rest of that chapter due the middle of that week. So I'd go back to my date view. And in Chapter 4, I'll take the rest of Chapter 4 and assign that for, let's say, that Wednesday. I won't do the mastering review. I'm going to set those up later so they can use it for studying for exams. So I'll have those due on October 4th at 11 p.m. I'll apply that. And if I want to change those later on, I can just change it. It's not a big deal. If you, of course, move the dates up, that might be bad for the students. So that's how you assign things. And if I go back to the date view here, now when I go to next week, I see that my October 1st ones are due on Sunday, October 1st. And on October 4th, I have the rest of Chapter 4 due. So that's how you assign things. How you see how things are, how your students are doing is the gradebook. So I'm not going to do that right now because you would see all my students and I'm allowed to show you that. So if you click on the gradebook, it gives you a list of all of the students you have and their grades on all of the assignments they have. And you can just download that into Excel or other common learning management systems also will link into it. So you can easily go look at your students. When you are in the gradebook, you can do things like give students individual extensions for particular assignments. You can just change their grades on particular assignments. You can see how much time students are taking, how much time they're spending. You can see how the class overall is doing on any particular thing, and you can get diagnostics of a lot of the kinds of things you're doing by your students based on things like learning outcomes or course goals or chapter goals. And so you can essentially look at that visually as well as download all of that. And so that's basically how the instructor side works. It's fairly fully fleshed out. You pretty much have all the control you want. You can make adjustments to how the assignments work, and it's pretty easy to use. It's not particularly complicated. So, Janet, I think that's what I had to say for today. Is that can you think of anything else I should add?
I think that's good.
Okay. So,
all right.
If anybody's watching this, thanks for listening. And if you have any questions, get in touch with us. We're happy to help. We're excited that you're using this or interested in it, and we're really proud of it. So, thanks.
Thank you very much, and thank you for joining us.